Hey guys, welcome. And I am now home in Phoenix, Arizona. And so I'm in my kitchen, the kitchen that I grew up in. It's Thanksgiving, and the yams are brewing, and everything is just like the season of thanks is beginning. With 5.6, we're looking at segments in a triangle. I can find three altitudes, medians, perpendicular bisectors, and angle bisectors of any type of triangle. So altitudes, medians, and perpendicular and angle bisectors. All right, so let's figure out what those are. Okay, so first we start off with segment midpoint. And so a segment midpoint is a point in the exact middle of a segment creating two congruent segments. So this one you probably already know, but I just wanted to make sure that we're all on the same page. So this section, we're going to be focusing on the definitions, and then the next section, we're going to be focusing on the properties or theorems. Okay? And so as we can see here, M would be a segment midpoint because it splits AB into two congruent segments, AM and MB. Next, we have a median. And a median is a segment that joins the vertex and the midpoint of the opposite side. So, for example, this is a median. This blue line is a median because it goes from the vertex to the midpoint of the opposite side. Let's see if I can get it. So here's the midpoint, and so we can say like this is congruent to that. So there are three medians for every triangle. So vertex to the opposite side. So we can say this part is congruent to that part, and like this point would be the median. Also, vertex to the midpoint of the opposite side. So this would be congruent as well. So we have three medians. Okay? Next is angle bisectors. So remember, angle bisectors cut an angle in half, or a segment that creates two congruent angles, splits the angle in half. So our first one is here, and we can say that basically this angle is congruent to that angle. Let's call this x. So angle ABX is congruent to angle CBX. We can create angle bisectors with all three angles of the triangle. So we can say that this angle is congruent to that angle, and then we can also say that this angle is congruent to that angle. All right, so angle bisectors simply cut the angles in half. Okay, for now, these are just sketches so you can approximate them. A perpendicular bisector is a segment that is perpendicular with another segment and goes through the midpoint. So MP, in this case, is a perpendicular bisector because it's bisecting AB. It's bisecting AB, and MP is perpendicular to it. Also, point M would be the midpoint. So the perpendicular bisector has to go through the midpoint of a segment. Now, in a triangle also has three perpendicular bisectors, one for each side of the triangle. So MP is the perpendicular bisector to side AB. Then we can have another perpendicular bisector. Let's call this one Y. So YM is a perpendicular bisector to segment AP. So it'll be perpendicular, and these are congruent. Boom, boom. And then we can also have another one. So this line right here, this blue line right here, is also a perpendicular bisector. Boom, 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 boom. Okay? So basically, it's three lines that are perpendicular to the side that goes through the midpoint. Lastly, we have altitude. And the reason why I showed the video of me skydiving was there was a lot of altitude, and that's probably where you've heard the term altitude before, like how high you are. And the altitude of a triangle is what we consider the height of the triangle, how high or how tall the triangle is. And so how you figure that out, so an altitude is a perpendicular segment that joins the vertex and the opposite side, and the opposite side of the vertex. So it's going to go from the vertex to the opposite side, and it's going to be perpendicular. So this line goes to the vertex and is perpendicular to AC. It's not necessarily a perpendicular bisector because this point is not the midpoint necessarily. In this case, it's just simply what's directly below B. And we can have 3 altitudes, one for each point, one for each vertex. So the next one, so here C, and then we have to make sure that it's perpendicular to AB. So we can go like that. And then lastly, going like that. So this is perpendicular. So vertex perpendicular to the opposite side. Not necessarily the midpoint though. And so those are the 4 key terms: median, angle bisector, perpendicular bisector, and altitude. So now let's try to identify these objects. I'll help you with some signage. Maybe that will help you out a little bit. And then boom, and this is also boom. So AB goes from the vertex and is perpendicularly down to the opposite side. So that would be an altitude. AC creates 2 congruent angles at the vertex A, so that is an angle bisector. AC is an angle bisector. And then AD goes from the vertex to the midpoint of the opposite side. That's called a median. And then ED goes from the midpoint of one side and then it's perpendicularly up. So that would be a perpendicular bisector. So these are the 4 segments that are the key to this unit, to this section. Okay, so let's take a look at medians and look at medians of acute, right, and obtuse triangles. So here we go. So remember, it's vertex to midpoint. So vertex to midpoint. So I can say these 2 are congruent. Vertex to midpoint. I can say that these 2 sides are congruent. And then lastly, vertex to midpoint. So I can say these 2 sides are congruent. Okay? So it's always vertex to midpoint. Now try to do that with this right triangle. If you didn't know, we're on the back side of the notes now. So vertex to midpoint, boom, boom. Vertex to midpoint, we can say these are congruent to each other, saying that this is the midpoint, vertex to midpoint, and lastly, vertex to midpoint. Okay, and then lastly for obtuse, vertex to midpoint, vertex to midpoint, and vertex to midpoint. So medians are vertex to midpoint. All right. Now altitude. So remember, altitude is vertex and then perpendicularly down to the other side. So it's just gonna it'll be vertex perpendicularly down, vertex perpendicularly across, vertex to the other side that's perpendicular. Okay, so those are the 3 altitudes. For right triangles, they're a little bit different because here's the vertex for this one, and where's the other side? Right here, right? And if this is a right triangle to begin with, well, how would we get from here to this side that's perpendicular? Well, it's actually this side is already the altitude. Same goes from here to this other side. This is going to be the altitude. And then lastly, here's the vertex and the other side. So it's just going to be perpendicular that way. So right triangles look a little bit different. Then obtuse triangles are even more different. So we have a vertex, and we need to be perpendicular to this side. But all of the lines inside this triangle, will never be perpendicular. So what we have to do is extend this line out so that we can then create a perpendicular line. And so the line that's the altitude for this obtuse triangle actually needs to be, the altitude ends up being outside of the triangle or on the exterior of the triangle. So this part is pretty, here's the vertex and here's the side that it's perpendicular to. But if we wanted to, you'll see why I drew that one in the next unit. And then lastly, to get from this vertex perpendicularly to this side, we need to extend this side out a little bit further and then make it perpendicular like so. So altitudes are a little bit more complicated with right and obtuse triangles. Angle bisectors, they bisect the angles or cut the angles in half. So with angle bisectors, all of it is always going to be in the triangle. So we create two congruent angles, and two more congruent angles. All right. Now try it with the right triangle. Yep, again, we get two congruent angles, two congruent angles, and two congruent angles. Note that the angle bisectors do not necessarily hit the midpoints of the opposite side. These are, the point of intersection here is not necessarily the midpoint. Typically, it's not. All right, and then for the obtuse triangle, bisecting these angles, bisecting these angles, bisecting. Okay? So that's angle bisectors. And then lastly, we have perpendicular bisectors. So remember, perpendicular bisectors have nothing to do with the vertices. All the other ones have something to do with the vertices, but perpendicular bisectors don't necessarily go through the vertices. So we go midpoint and perpendicular. So we have this side, and here's the midpoint, and so boom, boom, and it's going to be perpendicular, and just go straight up. Now from this side, we create a line that's perpendicular, so creates a 90-degree angle, and that's at the midpoint, so it's a perpendicular bisector. And then lastly, so this side, we're going to create a line that's perpendicular that goes through the midpoint. So here's the midpoint, and then this line is perpendicular to this side. Try to do the same with this right triangle. Create a line that's perpendicular to this that goes to the midpoint. Create a line that's perpendicular to this side that goes to the midpoint. And then create a line that's perpendicular to this side and goes to the midpoint. So there's that one, and that one. And for the obtuse triangle, I already created one for you guys. But there's another one. There's 1, 2, and 3. So it ends up that we can extend kind of beyond the triangles. Okay? And so what you may have noticed is that through all 4 of these segments, the median, altitude, angle bisector, and perpendicular bisector, that when we create all 3 of them in the triangle, they meet at a point. And we're going to talk about what those points mean in the next section. So now please attempt the 5.6 online quiz and then come to class ready to do the 5.6 application. Have a good one. Bye-bye.